The first speaker is Michaël Larouche. Michaël is from Quebec and has been working in the gaming industry since 2010. Instead of waiting another 10 years for the next best programming language for video games to be released, he decided to try out Zig today. The talk is using Wwise audio middleware in Zig. Michaël, the stream is yours.
Yeah. All right. Hi, I'm Michaël Larouche for those speaking French, or Michaël Larouche for those speaking English. Today, I'm going to present you a demo I did for my coworkers. So I work at AudioKinetic, the company that do the wide audio middleware for games and interactive, any interactive audio stuff. So I did a demo that shows, okay, this is really easy to bind C and use and bind Wwise in Zig. So first of all, I will show you the final demo. So this is using quite a bit of technology. This uses Win32 Windows, DirectX 11, and Dear EM GUI, as you can see right there. So for demo that shows various functionality of Wwise. So first is a location demo, so which means that with the same event, I will clarify that the okay. I'll clarify the term of Wwise. So in event, I will show the Wwise, the authoring tool later. So
hello, how are you?
So now I can hear hello, are you in English? And I switch in French. Play the same button.
Bonjour et bienvenue.
And we hear the same phrase in French. So Wwise has a built-in functionality for localized voice, which is really important for games as well. So the second one is RTPC demo, which RTPC means the real-time parameter control. So this is a value, a float value sent from the game to the audio engine. So with that information, you can modulate anything you want audio-wise. You can modulate the pitch, you can modulate the volume, modulate the level of effects and things like that. So for this one, this is a car engine, so it will modify the pitch in real time when I move the slider. So we'll start the car and then move the slider. And there you go. So the third demo is a footstep demo. So the Wwise has a concept of each object as an hierarchy. So you can define, okay, I have a single event called play footstep, and you can and the game can set and tell, okay, I'm on grass, I'm on wood, on a metal, on gravel, and depending on how you configure your sound and what in the authoring tool, it will play different sounds. So if I walk, I'll have some weight as well. So this is dirt. You can hear it's wood. And play the same event, but only the switch. They switch the surface type. So it all makes sense when I show the correct noise. Gravel, and we hear metal. Right. And the last one I did is subtitle demo. So what it is you can put marker inside a WAV file and add subtitle information if you want. And you register, and when you play an event in Wwise, you can register for callbacks for info. So you can get the marker info. If you play music, you can get the beat per minute and do crazy stuff with that, with the music. And you can also get an event when the event is finished playing as well. So
in this tutorial, we will look at creating actor mixers and control buses. We will also look at the actor mixer and master mixer structures and how to manage these structures efficiently.
So the text that you saw is not in my program. It's inside the WAV file, and Wwise just giving callbacks with the strings. So that's it for the demo. Before going to the code, I'll show you what Wwise is. The authoring tool. So this is the creation tool. We have the audio, which is all where you place your sound, and your buses. Buses is just let's say a specific output channel if you want. a virtual output channel. So we have the master bus. You can set the volume of the bus. You can have sub buses, for instance, music. So if you want to control your music independently from the SFX, you can do that. And also inside the buses, you can have auxiliary effects, which is to put, for example, a room reverb, for example, to have more depth to the space. And in the actor mixer hierarchy, this is where you define sounds. So here we have the localized sound we played earlier. So as you can see here, we have English and French Canada. And so if you're playing the
Hello, how are you?
And then switch the French language and play the same event, they play the same audio.
Bonjour et bienvenue.
And for the footstep, here we have a switch container. So let's grab here. So we have a hierarchy that says, okay, they predefined switches in the project at first for surface. So we have dirt, gravel, metal, and wood. And you can assign in the subtree, you have dirt, gravel, metal, any, and you can specify randomized content and things like that. And you also have interactive music hierarchy for music. So I didn't put music in my demo. Well, I could just show you really quick what it does. So I have my in-game music. And if I do this state, so now I do exploration music. If I switch the state, then we'll go and fight music. If I'm dying, the music will change. If I win, and that's basically all the other tools. So to communicate with the game engine, you need a use called event. So event can be a simple play this target, play this, play that, play this item in the R key we saw here. Like you see the hello there, that's the same hello here. If you go to the footstep, say play footstep, and this is the R key we saw here. So in the game, you just use it, you just post event and load some banks, where in some banks that's where you specify, okay, for the BMG, I want this hierarchy include. For the surface, I want the footstep, but only the dirt surfaces, and so. And also, so the event you can also only do play events. So if I go back to here, I can do stop all, pause, set bus volume, modify pit voices, and set game parameter Chico. So this is quite flexible. So for our game integration point of view, just okay, I want this event to play here, and then the audio designer can just go in Wwise and do his stuff that he knows best. That's the main point of Wwise. And also for the game syncs, yeah, the switches that define the surface. Here you can see the dirt, and the game can tell on the specific specific object that's playing the sound that okay, I'm under gravel, metal, and wood. Same for the so switch are per object, and state are global. That's the main difference between the two, but they pretty much do the same thing. And we have the game parameter, like I tell, was a float value, and can specify the min and max, the default value, and so forth. And triggers is for music. So let's say you do like a critical hit in a action RPG, for instance, you can have an accent in the music using triggers that come from the game. So this is why is the auto-oriented. So now let's go to Zig. So this is my main function. So like I said before, I'm using Win32. So Unfortunately, right now Zig doesn't see import the Windows header correctly, so you have to translate the Windows header and then do manual fixing to make it work. So that's why I'm using import 32 here. Here, same for Direct 3D 11. So let's see for it. So the Windows stuff is pretty basic. You register your Windows classes, you create new windows, and I'm using the NC version, not the Unicode version, to be simpler to integrate in Zig. Here I create my D3D device. Here I'm using my own Zig binding of Wwise. They're getting the path of the current directory to point to the generated subbank windows, because you need to point to the and why is there a concept of IOC? Because Wwise is supposed to be integrated into a custom game engine, so you have to specify you specify the Wwise using IOX, or and they'll input IO basically. So in here you specify, okay, so my subbank will be here, and the default IOC that we'll see later will be loading. So here I load the init bank. So there's the bank that contains all the bus hierarchy basically, and plugin informations. Here you can see I use differ. Here register a game object. A game object is an object that you place on that pretty much it. And a listener is just the microphones. So you need to place, because it's meant for 3D games, you have to place the microphone inside your URL, and then automatically, if you have a 5.1 sound system, you will distribute the sound if you want across all the speakers around you. So and you need your microphone to specify. Like, you can have multiple microphones depending on the situation. So I set here the full listener, which is using the game object. Here I set up EMGUI using the C binding to EMGUI. So the dark, I use a custom font. I call the implementation unit Win32. I init DirectX 11. Here I use for the CL equator. I didn't want to get fancy. And here's my main loop. Just calling EMGUI, using EMGUI. And there, one power of Zig, that's really cool. So for all the demo you saw in the demo, I have a table that says demo data, which is the name of the button, and the actual instance, the install struct of Zig I will be using to display the demo, and this is inside the table. I'm not a compiler, and I just inline the display the button, to init the current demo, create a new one, init, and then show the current demo for the UR. Render to come call. I'll show you that now, and the Windows Plus, which is a C convention to do the resize for the target, and the win main for that just called main in game. Yes, I don't need the win main. So inside there we see comcall. Comcall, because DirectX is using comp, and calling comp from C or Zig, for instance, because Zig use the CVI when you is commanded with C. So I have to do a specific function that, okay, I want you to call on this object, this method, which is inside the V table, because if you go here, let's say, and here, so this is the instance we have, and we have a pointer to a structure, to a pointer to a V table, this a function, and calling that by hand was pretty tedious. So what I did a helper function called comcall that found, okay, I want you have the field inside the vtable pointer that called name, use the function to call and concatenate the arguments. So it simplifies a lot doing com calls, doing that. And using reflection, I can, find the type of the vtable depending of the self type, which is the type, let's say, for instance, the swap chain here. And then from the vtable, I have the stack of the vtable, find the return time of the function. So if the so here I'm finding the type of the vtable. So if I find it inside the struct, the pointer, something called LP vtable, that means okay, I got my vector field, and then I return the type here. And for the return type, I have to return the vtable type and just look for all the fields that have the same name, and then I know, okay, this is the function I need to call. So this is really, really handy to handle all DirectX related code. So DirectX is the same as you would do in C++, except for where's the GUID column? Sure, you have to do some crazy pointer cast, get the target view. I don't remember what the GUID is. Ah, there we go. This is so when you want to interface, this is what. Okay. So you can use also the DX grid to specify, okay, I want this version of the class when I do casting. So for those who are familiar with the RTX programming. So that's it for that. So let's say the build file. This is one power of the Zig build system. Like you can use no other build system and build everything from scratch inside Zig. So in the build, I have two static libraries and the main application. So I use a static library to create a wine binding. I link to a lot more system libraries. This is the standard C. This comes from Wwise. It comes to Central, the Roomberg, the Delay, Wwise decoder. This is the Windows library I need for the Wwise stuff. And I had to include here for the IO I put inside, and for the SDK. And as you can see here, the library will build within Visual Studio 2017, and it links no problem. So this is pretty cool. And if you build C code or C++ code, I really suggest you do an area of all the C file you want to build, and just do a for loop to add the C source file to your library project. So same for ENGUI, I just build the bindings, and then they implement the C++ implementation and the implementation for DirectX 11 and Win32, which come from the GitHub of ENGUI. So stuff here, add the C source file. What else? I need to link to the DirectX 3D11 and DirectX Grid, install, run, and it works. So if I go inside the source file for the bindings, so the Wwise binding was just a basic binding I did in C, as you can see here. I have to duplicate some enums and some enum from struct from Wwise SDK to be able to easily bind it to Zig and do just a C import in the code. So this is all done by hand, and just the minimal I needed for the binding. So I didn't do a full Wwise binding. And I think for the scope of the C++ API is not that big, but I would clearly use a tool to do automatic C binding for Wwise if I want to do this in a real game, for instance. So Zig Wwise and just forward the call to the C++ API and create anything the Sun engine here. So this is Wwise specific stuff. So I'm specific plugin one. And the IO hook is just a default IO hook that came from Wwise that says, okay, how do you want to load how you resolve the banks and the streaming file and all that stuff. Here for the EM GUI, just go to the EM GUI. So for the Wwise Zig binding, I just do a C import of the Zig Wwise library I did by hand. And then I do a nicer Zig interface on top of it. So I do an alias for the callback function, the correctability, the invalid game object is just a -1. Here, the callback type is a mask, so this is struct here. Here, call this the most interesting part are all handle string. So because Wwise use the native string, so if you're on Windows, use the WTF 16 encoding, so use the Unicode version of Windows to call it. So what I did to convert, I create a simple text string with an internal buffer, which is allocated on the stack, using the buffer allocator, and then I convert using the Zig convert to it from UTF-8 to UTF-8 with the null added at the end. If I need just the OS char, which is the basic C style char, I just add a null byte. All this, when I need, is done on the stack, so there's no heap allocation for strings. And we have 4K of buffers, so it should be fine. For all, you don't need to pass a lot of strings. So let's go on the API a little bit. First, a render audio is needed to signal to the Wwise audio thread that, okay, I'm done. You can process all the command I sent to you and render the final audio to the game. Set IO base path is for the IO to specify, okay, this is the base path where your data is. Very much. Load bank, so everything in Wwise need to be inside the song bank. You specify the event and the audio data included. So here I need to pass by string, so I need to convert here to OS char because this one uses OS char. Load bank, and then we convert the result to Zig error code. So you need to do try catch in Zig to get your unload bank by ID, because here we return the bank ID here, so we need that to do the unload. We can do unload bank by string if you want, which is thing. Register game object is very important to register. Okay, I want this game object to be. I want a game object is just a place where you can play sound and Wwise. So it specifies the game object ID and the object name for the debugging purposes. And register game object is the same. So post event is using, it just post an event by string. You can also post event by ID, which is a 32-bit hash of the name. But for simplicity here, I just use a string. Post event with callbacks, which is an override of the same function. So yeah, pose the callbacks with a cookie, which is user data basically. Set RTPC value is always set the value for the car engine demo. So you specify the name, the value, and on which game object you want to put game object, which Wwise object to play to set the RTPC value. So yeah, each game object can have an independent RTPC value, so it's not global. So this is interpolate. If you want interpolation, when you modify your RTPC value, split position is not really get to plug the position of where the sound is currently in. Stop playing ID, stop all on game object, or stop all everything. Set the flow listener for setting the microphone. Set current language is for the IO, so for the streaming manager. So to tell, okay, now you're playing English sound, now you're playing French sound. Set switch for setting the switch on the object. And here, to char using the power of Zig to do a FL does and much more cleaner to get, okay, I'm on Windows, but use the JS16 to convert to char. Or if you are on under system or on a senior system, you use the F8 and just add a null byte. All right. This is just the import. So let's do the subtitle demo. So in my demo, okay, now I have the demo interface. So I have to do a bit of orange up OOP, object-oriented programming. So I did it. I have a list of function I wanted to call. So basically the V table here, the demo interface. I didn't use the Alice Snacks Zing interface for this, but in the future, I think I will use that library instead. But by hand, this is how you do it. To have, so yeah, you have the instance and all the function and call. And I just type decay the struct to a new pointer to it, and then the function will be solid with no problem. So this is the structure that's just an helper function to call directly the show. So you don't need to specify by hand, okay, I want pass the instance directly. So this is helper function. This is the null demo that just do nothing, basically. And this is the method that return the demo interface that will contain the instance pointer and pointer to all the function of the demo. So this is how you simulate basically vtable for now in Zig. Inside by hand. So obviously in the future, it should be a better way to do this. So for subtitle demo, my subtitle contain the text, the index, the position. So here for the demo, I just load the required bank for the subtitle demo. And I register a game object here for playing this. And what else? On UI, when I play the button, I post my event with callbacks, which is the name of the event, the game object ID, and what information I want from the callback. So I want the marker information, which is the actual callback that contains the subtitle information, the end of event, and the get source play position to for displaying the timer, the microseconds, so in the demo, and the function, and self would be the user data. So inside here, which is a C API function, I get my marker, I check the cookie. This is valid, which is the self. Because it's back to the demo. I get the marker info, and then I set the marker to subtitle text and get the position. And what is the subtitle to the allocation here and the duplication here. And this will see for the demo, so you can see the context. And after that, we'll be done. So here we can see this is the play button, the same play button here. And
in this tutorial, we will look at creating actor mixers and control buses. We will also look at the actor mixer and master mixer structures and how to manage these structures efficiently.
So the play position, where is it set? Okay, this is why I get source play position. So I get on each frame, I just get this position. So okay, that's how I do it. I did the time position and display the text. And here for the get interface, I cast change the type to self and just pass the function. And what else? Oh yeah, I'll show you one more thing. So I close one, so I just reopen it pretty quickly. So I have my game here. This is the profiler view in Wwise. I will connect to my demo, which is in Zig, as you can see here. So the profiler will tell me when a sound is playing. So I'll go to location demo, for instance. So here you can see, you unloaded this bank, and you unloaded this bank, and you unregistered this game object and registered this game object. If I play,
Hello, how are you?
I'll just play that again.
Hello, how are you?
You can see the whole path of
Hello,
the sound
how are you?
in the all the going from the sound to the output buses. And same for the RTPC. All right, so that was my demo. So I've been looking for a C++ replacement for years. I mean, I tried D, I tried Rust, and Zig so far is really the language I'm really happy to finally tell that this is my C++ replacement. Seriously, that's why I bought the T-shirt. I'm really fall in love with the language. Andrew did a really great. Andrew and the community did a really good job designing and implementing the language, and really looking forward to 1.0. And we'll contributing whatever I can to the language and the libraries.
Okay, Michael, thank you very much. Let's move to the Q&A now.
Yeah.
So while people start typing down the questions, I have a couple of ritual questions for you. So the first one is, of course, how did you discover Zig?
I heard about Zig on Reddit. Something like I saw several posts of Zig. It's like, okay, this is like a C replacement. Want to be better than C. And then when I saw a post about the road to Zig 1.0, I thought first of all, okay, Zig is close to 1.0, so I should check it out. So I listened to Andrew's talk when he shows comp time, features, and tool system, and the fact that Z is a C compiler, I was blown away. So when I saw the demo of cross compiling features, the first thing I thought, okay, I need to try this on. Okay, LLVM support the GPA CPU, and makes me get it. So yeah, first thing I did. That first thing I can talk. I can at least talk. Yeah. So first thing I thought, trying to get Zig to run on GPA. So
I see. Cool. Second question. So tell me if I got this right. So when you are working on a video game, like professionally, you have audio engineers that don't want to know every single possible game engine in the universe. So what Wwise middleware does is basically it's a standard platform interface for them to design audio with, and then on the other end, game engineers can interface with Wwise middleware to then wire everything together in their custom engine. Is that correct?
it is very correct. Yeah. So yeah, it is a standard now. It wasn't in the beginning, obviously, but pretty much all like he used Frostbite in EA as his own game engine. Not every AAA use Wwise, but a lot of them use them. So just this year, the game that used Wwise was Doom Eternal, for instance, use Wwise, which is other big games that's just this year. Unfortunately, the remake of Final Fantasy VII doesn't use Wwise. I don't know what they use, but so yeah, it's a standard. So it's really tailored for audio designer to integrate the sound into the game and design interactive audio with it.
I see. I think I saw Overwatch also mentioned on the Wwise website.
Yeah. Blizzard started using Wwise with Overwatch, I think, and will you use that in the future as well for future games. Before they use Fmod for.
Oh yeah.
Before that, you use Fmod for StarCraft 2, use Fmod, for instance. So what was the first one?
So on the topic of Overwatch, I've been playing for a while and I'm stuck in Diamond. I'm clearly Grandmaster material, but I think the game keeps giving me bad teammates. Do you know anybody at Blizzard that could help with that?
I don't know. I know that at the Kinetic there's several Overwatch playing. I'm not one of them, but there's some people that play Overwatch at the work.
I see. Okay, so let's start with the questions from the public. So the first question is, did the demo get your colleagues to try out Zig also?
I don't think so, but they got them curious for at least. I got several comments that's like when I did my presentation at work, I presented the Zig language as well, and I get several like holy shit moment. Like when I did the comp time features and cross compiling, and the most reaction I got the interoperability with C was a big winner.
Another question: how was the experience interfacing with C++ code?
I mean, it was tedious because you have to do the C binding by hand. So, but this is the nature of C++. If you want to use C++ code from another language, either you do the C binding by hand or use tools to do that. You can use Swig, for instance, but Swig is a pretty hole, so but it's still working. So we use Swig and working to do the C# binding for Unity. So yeah, you need to have the C interface in the end to be able to use C++ code. So it's your choice either to. So I hope somebody will do a better tool than Swig one day that use C-Clang for parsing the headers. But for now, it's either you do it by hand or you write your own tool.
How much time did it take to get the demo up and running?
I did that like on my lunch work hours, and took me, I would say maybe in total maybe 2 days added, but it took me months just here and here working on it.
I see. So did you feel productive while developing it?
Yes, a lot. Like Zig is so much productive. It's insane.
What feature of Zig do you find the most valuable for this type of work?
Reflection for what? Reflection is a big topic in game development because every C++ engine that you, even commercially or commercially, I mean by that, like it's Unreal, or like even property engine in King Company, let's say at Ubisoft, the engine that we use on Assassin's Creed was a custom or the in-house engine, and we did our own in-house reflection solution. So everyone need to augment C++ ability for reflection, and let in Qt as well has to do that, and you get a lot of flack for using an external tool compiler, but to redo reflections solve a lot of problems. So outcome time reflection is really handy.
Okay, I think we went through all the questions. Thank you again, Michael. Is there anything else that you want to say?
Check out, I need some, right now I'm working on I'm doing the P where Win32 support in the Sepals compiler. I'm not far away, I'm just figuring out the format right now. So if anyone want to work on an image format library, I will gladly to have people helping out on that, because I won't be working on that for a while. It's because I want to work on the Sepals compiler.
Okay, awesome. So, I mean, everybody heard the call to arms. So if anybody is willing to help, I'm sure they will. Thank you again. Thank you very much.
Thank you for doing this. It's pretty cool.
Thank you.